This video is on 7.3, the double angle formulas. So we have the list of double angle formulas over here, and if you've Googled, you may even find some other variations. So notice that there's two different versions of the sine of 2 theta, and this is like we had talked about in video 1, where we have the identities. So what you can do is you can switch the tangents and the sines and the cosines around and use that Pythagorean identity to change forms of things. So that's why we have more than one, and if you Googled, you might even find other ones. So, but these will be all you'd need to get through the problems in XYZ. So we're going to try these out. So the first one, I have it in this form over here. So just kind of like we did with our sum and difference formulas, I match it up and I say, okay, this kind of looks like one of these versions where it has the the 2 cosine squared minus 1. So here he is, 2 cosine squared of something minus 1. So I'm going to switch it from this version on the right to this version on the left, where that's going to be the same as cosine of 2 theta. In this case, the angle was 112.5, so 2 times that 112.5. Okay, so notice I don't have it squared, I don't have it 2 because I went from this form to this form. So these are two equivalent statements. These would give you the same exact angle. In fact, if you were to type this into your calculator, you would get a certain decimal answer, and it's going to be the same as the decimal answer that I'm going to get over here. But we'll be able to find it in its exact form because 112.5 times 2 is exactly 225, and that is one of them that we have on our unit circle. That way we can get it in exact form like they ask us for it on XYZ. So 225 is down there in quadrant 3, so we know it's going to be a negative, and cosine of 225 is right there, halfway between 180 and 270, giving us that square root of 2 over 2. Okay, so again, this as a decimal is exactly what I would get if I typed this into my calculator. So these would be the two equivalent angles. Okay, now this one right here, you say, okay, it kind of matches up with this guy right here, except what's it missing? It's missing the 2. Well, that's just a regular old standard, whole number, so we can work with that. So I say, okay, it would have matched if it had the 2. Now I can't just magically change things because I want to, so of course if I put a 2 there on the top to make it match, I need to put a 2 down on the bottom. I'm going to keep that 2 separated right here because I'm trying to make it match this formula. So that 5 pi 8ths on the top and on the bottom now fit into that form. He matches up with this form right here. That's an 8. There we go. So it looks exactly like this now. Now notice this 2 right here was just to balance it. This was to make it match. This was because I can't magically change things. So if I put a 2 on the top, I need to put a 2 on the bottom. Now that it matches, I'm going to switch it over to this form of tan 2 theta, tangent of 2 times that 5 pi 8ths. Okay, but remember that when I put this 2 here, I had to balance it by doing a 1/2. Only this inside of the parentheses turned into this over here, so I do still need that 1/2. It was 1/2 of all of this stuff, and all of this stuff turned into all of this stuff right here. I'll put a little squiggly line to match them up. Those 2 squiggly lines just changed from one form to the other. So again, the reason that we did this is because 2 times 5/8 turns into 5/4, which is one that we know on our unit circle. Okay, 2 times 5/8 is 5/4. And 5 pi 4ths, that would be in, let's see, quadrant 3 again. So my 4 looks like a 9. Here we go. Okay, that would be a sine is negative square root of 2 over 2, and cosine is also negative square root of 2 over 2. If you did like I recommended and went ahead and filled in the tangents of each angle, hopefully you already know that that would just be a positive 1. So 1/2 times 1 is, of course, 1/2. And that's it. All right, so then we get to use our triangles again because triangles are their favorite things. So right here, let's put our triangle up here. Okay, this will be the triangle for A. So it tells us that the tangent is 12 over 5. Remember that that is opposite over adjacent. I just ignore the negative for now. I know he's in quadrant 4, so I'm just going to keep that in mind for later. Okay, I'm going to use that to figure out who's positives and who's negatives. Okay, so in quadrant 4, I need it to have the short side squared add up to the hypotenuse squared. Here's my mystery. Okay, my Pythagorean theorem. This is going to give me 25 and 144, which makes 169, which is luckily is a perfect square of 13. So x right here is 13. Okay, so I always had to kind of step to the side and do this piece of information to get these three numbers, and now I can go do what I need to do. So now it's asking me, kind of like we did here in the sum and difference formulas, just to kind of break it down into these simpler ones with the little pieces, just like we did right here. So it says that the sine of 2a, which right here and by the formula is 2 sine of theta cosine of theta, which in this case would be a, so 2 times sine of a cosine of a. Now that I've found all the information about a, I can fill that in. So 2 sine of a, well, in quadrant 4, okay, the sine would be negative. Okay, opposite over hypotenuse. In quadrant 4, the cosine would be positive, positive 5 over 13. So again, the most common mistakes in these problems are the signs, S-I-G-N. So make sure to always take a step, double check that all your pluses and minuses are where they need to be. Quadrant 4, sine was negative, cosine was positive, and then move forward. So right here, I can just do the rest of this in my calculator, punch in those fractions, and I would get negative 120 over 169. Okay. Now for the cosine, I have all these options here. I have all three of these and even one down here. So I can choose whichever one I feel like. Both sine and cosine are pretty easily attainable. I could use one of these right here and only use one or the other. Sometimes you'll see an advantage in one of those. They might have only given you cosine, then you wouldn't have to go through the trouble of finding sine, stuff like that. But let's just go ahead and use this top one. So cosine of theta squared, we decided that that was positive 5/13 minus the sine of theta squared. Now sine was negative, be careful. When I square that negative, as long as I do my parentheses very carefully, that does become a positive. So that would give me 25 over 169 minus 144 over 169. They do have that common denominator, so I don't have to get a common denominator. That gives me a negative 119 over 169. Okay. Now cotangent, notice looking through our formulas, we don't have cotangent. You could go online and look for it, but remember that cotangent is just tangent flipped over. So if I needed cotangent of 2 theta, I would just take this guy right here and flip him over. It would be 1 minus the tan squared over the 2 tan theta. So we're going to do that. We've already got all of our information here, so let's go ahead and put it in. So I flip it over, so the 1 minus tan squared is on the top, 1 minus tangent in quadrant 4 is a negative. It was opposite over adjacent. In fact, that was what they gave us there, 12 over 5. Okay, and then he's squared because it's 1 minus tan squared. That is on the top because we had tangent here. This is cotangent flipped over. On the bottom, we'll have 2 tangent theta, okay, which is the same 12/5, negative 12/5. Let's clean that up just a little bit. So that would be, remember that they square the negative first, which makes it a positive. So it'd be 1 minus still 144 over 25. And then this one would be negative 24 over 5. Okay, now you could use your trick where we multiply everybody by a 25 to get that to clear out. You could use your calculator. If you do the calculator, I recommend doing it in steps. So just type in the 1 minus 144 over 25. Do just that part first. And that's going to give you, as a fraction, the negative 119 over 25. Okay. And then we could do our copy dot flip, or if you do type it into the calculator, you have to be careful to use parentheses. So you would say parentheses, this fraction divided by parentheses and this fraction. And since it's easy to forget those, I really like doing the copy dot flip right here, because then it's just easier to see where everything goes. And you can even type it into the calculator after you copy dot flip. 25 times flipped over negative 5/24. Okay, and that's a 24, not a 29. I don't know why it always does that to me. There we go. All right, and then of course those 5's reduce, and it cleans up to be negative times negative is positive 119 over 120. Okay. So those are the double angle formulas. Next we'll do the half angle formulas right here. They're just a tiny bit trickier, but it's basically the same idea. As always, let me know if you have questions.